really cool thing that happened was some of the .svn directories that store metadata got blown up. I don't know how that happened. I thought one of the ideas of version control was to make that sort of thing impossible. But it happened, and that was really fun to fix. So what you're seeing here actually is the fix to the copyright issue. You might be able to golf this down a little bit further, but I was pleased that it fixed all the copyrights very quickly. So, and this also, I don't know whether for or against, but I believe this is evidence with respect to Jamie Zawinski, father of Netscape's argument, that some people, when they see a problem, think, I know I'll use regular expressions, and now they have two problems. I don't know whether this is for or against that, but... So in addition to this, the major refactoring work with respect to splitting the header files up and putting them in a logical structure and putting implementations in CPP files is ongoing. I haven't been able to commit the changes yet because it's impossible to cross a chasm in two small leaps. Basically, I haven't been able to get it so it's in a consistent and usable intermediate state. So that'll be a big commit once that's all working, but for now, the header update, the copyright statements at least are correct. Now with respect to unit tests, the fact that our test harness was broken was actually sort of a blessing in disguise because it never should have been shipped with the product anyways. But basically what I wound up doing was I found a library in C that has no external dependencies that got released actually I believe the beginning of September called libtap that had the exact same interface as the library we were doing because it was just a different implementation of the same tap testing library, testing framework. So I wound up doing a switch to this, which wound up being a big win because it reduced the number of external dependencies the project had, and also was a little bit more cleanly implemented. So it was sort of a blessing in disguise that breakage had occurred. The fixes to the adaptive part are something that's going to be ongoing throughout the semester. We want ARM support, including ARM Neon. Neon is ARM's SIMD implementation. It's sort of an analog to MMX and SSE instructions. It even has a test platform that I showed you before. Hello. And there's some other miscellaneous things that are going on. Shortly, Jarell is going to tell you all about how the timing platform, which was his primary responsibility, among some other things, during summer development, is now its own project. So what's going to happen there is, seeing as it's no longer part of the core project, we shouldn't really ship it. We should be a consumer rather than a provider of it. So that's going to happen. Some consistency issues with the code. You know, some of these things are simple things like brace and indent style, you know, naming conventions and things like that. And also, when we started the project, we were actually really good about putting Doxygen comments in every function in the implementation. As time went on and time pressure was applied, that didn't always happen. So that's a little bit of cleanup work that will be ongoing during the semester as well. Any questions?
You said you only work on SSE3, but AMD has a library that will do the equivalent of whatever SSE intrinsic you're using in SSE2 or wherever.
Yeah, that's one of the adaptive bits there is that that needs performance testing before we can just blindly use that, because if we just had the AMD implementation for a given function use that wrapper, it might wind up being that, you know, the Intel implementation takes 20 cycles to do this function, and then the AMD cycle implementation, because it's using this wrapper that guarantees correctness but uses, you know, SSE2 instructions, would wind up being slower. So that's actually a very good thing that, thank you for bringing up, that I will look into, but something that I couldn't just blindly apply, sort of.
Well, it's better than not working at all.
That's true. That is very true.
You talked about ARM supporting Neon. Is your implementation going to require Neon, or will it be optional?
At this point, I'm leaning towards requiring it, because anything that doesn't have it is probably going to be kind of dog slow, which would defeat the purpose of it. Also, I think ARM Neon is pretty much ubiquitous in the ARM world. There are ARM CPUs going back to, let's see, A11, I think, that support it, which was released in 2002 or so. So even cheap ARM processors these days support ARM Neon. So there wouldn't be too much of a win in having a slower path for things that don't have it.
Yeah, the only thing that I can, some of the earlier Android and iPhones were ARM v6, which is not.
Yeah.
But the new ones also.
See, but like for instance, this guy that I keep bringing up, this is an LG Optimus. This is like a $150 phone like 8 months ago, and it supports it.
Right.
So I think that, and additionally, the CPU instruction sets in phones are, well, CPUs in phones generally in use have a much shorter lifespan than desktop CPUs and things like that. So you do have the bonus for if you're a library implementer that that you don't have to worry as much about supporting older legacy things just because things get swapped out more quickly. You can keep asking questions, but I'm going to switch slides real quick. Here.
So can you confirm that all Neon is, like all recent smartphone chips have ARM Neon implementations? Does my iPhone support ARM Neon?
Your iPhone definitely does,
Okay.
yeah.
Back through what iPhone?
I believe iPhone 2.
Okay, wow.
So, which was, what, 07, I want to say?
08 for the,
08?
For the iPhone 3G, which is the second one.
Yeah. It's great to have a resident Apple, you know.
Something like that, yeah.
Notice I didn't say what Apple he was. I didn't say Apple apologist. I just said he was an Apple. Oh, and in the spirit of something, oh, sorry, I didn't realize there was one more question.
Oh, well, I was just listening.
Yes, this is a little bit of a bonus. Anybody here taking MAU or engineering probability or any of those things? All right, anybody have to take it in the near future? This is a tool I'm developing while I take the class to check my answers that if you're interested in, contact me at some point. This will be on, this isn't on GitHub yet, but it will be pretty soon. So you'll see TRAPINT there is a trapezoidal integral approximation. Having something like that in my little math library makes a lot of things easier because, you know, because a lot of the integrals that you wind up using in probability don't have closed form solutions, so you wind up needing to have numeric methods, and having some that are very convenient is a pretty big win.
So does your library have bindings to like Lisp then?
No, this is a bonus. This is
Okay, this is unrelated.
This isn't.
Okay, well, you said trap, but I wasn't sure if that was part of the math library.
No. I would say that in a gaming context, the moment that you start approximating an integral with a default of 2,000 steps, you've probably, you know, maybe if you're running on Boink, you can achieve 60 hertz, but otherwise you've probably, you know, given up the ghost.
I have one other question. You mentioned you have an inverse square root
Yes.
implementation. How fast is it compared to Carmax?
Actually, it was an implementation of Carmax that we used. And that's the one that ran in, I want to say, like 30 cycles or so. So that was a lot quicker than like x87 floating point instructions to do that. However, it was a lot slower than using one of the SSE instructions that basically did it in 2 cycles because it had a hardware lookup. See, but John Carmack was, well, actually, interesting story there. John Carmack, even though it's named after him, didn't write that in the Quake 3 source code. It was one of the programmers who was working for him, and he got it from a book of numerical recipes in C from the 80s. But it is interesting that these, you know, sort of esoteric techniques eventually bubble through to the mainstream community, and then somebody posts it on Slashdot or Reddit or whatever, and everybody just kind of, you know, there's one of the things that was, I don't know if it's a positive or negative, is that the Carmack technique there for the fast inverse square root had this really intriguing magic number in the middle of it. It was just a hex constant. We had a comment in our implementation of it that just on that line just said magic. See, there actually is a reason that that constant got used, but it'd be too long to go into here. But that was fun to have. I was kind of sad to see it go, but at the same time, you know, hardware lookup table you can't beat. Anybody else? All right, thank you very much, folks.